limit as n approaches infinity has to equal 0. If it doesn't equal 0, then it might diverge, but it diverges by nth term. And then we have to prove that our terms are decreasing in some way. It might be that we can just write them out, but if they're too hard to write out, we might have to do a first derivative test. Okay. All right. Oh, this one's fun. Doesn't that look like fun? Doesn't that look alternating to you? All right, let me find my cheat sheet notes here. Oh, not that one. Okay. No. No, let me go back to 2020. Okay. So the question is, how do I know that that is alternating? Okay. Because it looks really, really weird. All right. So here is how we deal with the fact that that one is actually alternating. Okay. If I think about cosine. Okay, so let's think unit circle for a minute. Okay. I know that this is 0, right? And I know that this is pi. And I know this coordinate is 1 and this coordinate is -1, 0. All right, I am putting in a 1 into just this numerator piece. That's it. So that means I'm looking for the cosine of pi. What's the cosine of pi? -1. Okay, then I'm going to put in a 2. What's the cosine of 2 pi? It's 1. Okay, let's put in a 3. Doesn't that put us back here? What's the cosine of 3 pi? -1. Okay, let's put in a 4. What's the cosine of 4 pi? Does it alternate? Yeah. Okay. You won't see that with sine because sine does the alternating at pi over 2 and 3 pi over 2, right? Not at pi. And so you might see cosine n pi, and that's the same thing as saying, so this is equivalent to the -1 to the n power. Okay, so we could literally just replace it with that, and we're good to go. Okay, so that's what I'm going to do. I'm going to replace it with the -1 to the n. And then we've got, I'm going to separate it as 1 over n to the 3/4 power. Okay, that I hate slashy fractions. I don't know why I wrote it that way. Okay, so I know I'm an alternating series. I figured out the -1 to the n thing. So first thing I have to look for, what do I test first? What do I have to do first? Just make sure that the limit as n approaches infinity is 0. So I'm going to do limit as n approaches infinity. Limit as n approaches infinity of 1 over n to the 3/4. Which means I have 1 over infinity, which is equal to 0. So step 1 checked off, right? Okay. Step 2 is make sure my terms are decreasing. Okay. When I put a 1 in this denominator, what do I get out of it? 1. So I know my first term is 1. My second term would be 2 to the 3/4 power. And then I'd have 1 over 3 to the 3/4 power. And then I'd have 1 over 4 to the 3/4 power, and so on. I'm not sure I understand if those are decreasing. I know they're decreasing if the denominator keeps getting bigger, right? Because the bigger the denominator, the smaller the number. So let's just double check. My brain would probably want to do this with it. So this is the same as saying the 4th root of 2 cubed. What's 2 cubed? 8. So it's the 4th root of 8. This one is going to be the 4th root of what's 3 cubed? It's 27. I don't know why. I accidentally erased it. All right, so 27. And then this one would be the 4th root of what's 4 cubed? Is my denominator getting bigger every time? Yeah, so is my series decreasing? Yeah. So do we converge or inconclusive? It definitely converges. Okay. So we would want to say something like therefore, and then whenever you're writing this out, you want to go back to what the original series was, even though we manipulated it a little bit. Cosine of n pi over n to the 3/4 power converges by the alternating series test. Now, they have said that AST is okay. I would still write it out if I was writing an explanation. I would write out alternate. It's not worth the communication error to the grader. Okay. Okay. Let's take a look at the next one. So we've got just enough time to probably do that one. And where do we go after that? Oh, we're almost actually done with these notes. Okay. Do we have an alternating series? Yeah, how do we know it's alternating? Yeah, -1 to some exponent, right? Usually it's an n or an n plus 1, doesn't matter which one. Okay, so I'm going to try my alternating series test. So, first thing I check is, what do I have to write first? Limit as n approaches infinity. And remember, I'm only looking at this piece right here, right? So n plus 1 over n. I don't worry, I ignore the alternating part. All right, what's that equal to? Aren't the exponents the same?
Yes.
Yeah, so what can I look at? The coefficient. What do we get?
1.
Ooh, did we get what we wanted? It's got to be equal to 0 for alternating to work. Okay. So alternating does not work on that one, does it? All right, but what did we just use?
Nth term.
That's nth term. Did nth term work? Yes. So does it converge or diverge? What's the only thing we can get off of nth term? It only diverges, right? So it just diverged by the nth term test. It's kind of a hidden little thing in there, isn't it? Okay, so we're going to write down what just happened. So it's therefore the sum as n equals 1 to infinity of -1 to the n plus 1 times n plus 1 over n. Again, I'm being very formal, even though it's still probably informal. I want to make sure when you go to college, you're ready for those professors. I don't know what they're going to do to you. Okay. All right. We know that it diverges. This is why it's important to tell me what test it diverges or converges by. Diverges by the nth term test. Okay. We will save the last two for tomorrow. Okay. And we will probably also move on to the next thing tomorrow too, because that's not a whole lot. So to do just those two examples. But that gives you all of about 5 minutes if you want to quickly look over anything before we start our quiz. Okay.